All right, what's up? Welcome back to another episode of How to Algebra, where today we're diving into the world of converting logs into exponentials. It's like unraveling a puzzle, transforming the logs into exponential form. So remember, logs are just a different way of expressing exponents. So when you're converting, you're essentially swapping one piece out for another piece. So let's embrace the challenge, embrace the math, and let's unlock those exponential secrets together. Let's get it. All right, converting between exponential and logarithmic forms. So the first thing is to understand that exponential functions and logarithmic functions are inverses. Now just remember what an inverse is, right? It takes in an input, in this case x, and it returns a y value. Right, you give me an x, I'll give you a y. That's what a function does. The inverse of a function takes in a y, right, the input, and returns an x value. So they, in a sense, undo each other, right? They're almost the opposite of each other, right? You give me an x, I give you a y. The inverse, you give me that same y, and I'll give you back the exact same x. That's what it means to be an inverse, simply put. So a log function and an exponential function. All right, so here, this is what a log function looks like, right? You give me an x, and the x goes here, and this will return a y value, right? You plug in an x, and then it'll return a number. So this is red, right? F of x equals log base a of x. So the little subscript, that's the lower number or the lower value, we call this the base. A couple of fun facts is that it's understood, right, that, for instance, when you have an x, just an x, right, it's understood that there's an exponent of 1, but we don't write the 1, right? It's understood that there's a coefficient of 1, but again, we don't write the 1, right? These things are understood. It's just known. So a fun fact is that when it comes to logs, if you have log x, all right, it's understood that it's going to be a base 10. This will come up in a little bit, but I'm clearing the air right now. So base 10, you would never really write base 10. You would just say log x, right? Like it's understood that when you don't write it, there's a 10 there. And a lot of people don't know this, but we work as humans. You've been taught the base 10 number system your entire life, right? And it's typically because we have 10 fingers, right? You count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then it starts over. 1, 2, 3, 4, 5, 6, 7, 8, 9, 20, right? Typically it's 11, 12, 13, ... And then, every 10 digits, we add another 10, essentially. And it's typically because we have 10 fingers, right? Had we had 12 fingers, then we would use a base 12 system. And technically, we kind of do use a base 12 system when you look at a clock, right? It goes 1 o'clock, 2 o'clock, 3 o'clock, 12 o'clock, and then it starts over 1 a.m., 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 1. That's base 12. So a little fun fact. Okay. So we're clear on that, right? Just 10, it's not typically written. So you're going to see it as just log x if and when you see it. All right. You can convert, right? You can convert any log or any exponential back and forth. So here's the rule, right? Now, I get it. There's letters all over the place. So if you don't like letters, if you're more of a visual person, that's not a formula person, a way I like to think about it. All right, whatever that is, the base, that's the base over here. Okay. All right, so some people might like this better. If you just look at where the pieces go, you're going to be given one of these guys. One of these guys, right? Either a log, and you're going to ask to convert it to exponential, meaning no log and with an exponent, or you're going to be given an exponential and asked to convert it into a log. So if you can just remember where the pieces go, right? It's just like a puzzle. You're just moving pieces around. Now, one thing I will say, when you have a log, there is this nice little swirl method, right? So what I'm saying is, when you have log base whatever, in this case, a cloud. So the cloud or the base is going to get raised to whatever the value is outside of the equal sign. Right, in this case, it's a triangle. And then it equals whatever so the part that's here, right, the X part, it's the input, right? Or some people call it the argument. Or the input. I like argument, but that's just what I was taught. So you take the base, you raise it to whatever it's equal to, and then set it equal to whatever the argument is, or the input of the log. In this case, it's a square. So that's exactly what's happening. So it's the cloud, right? And it's raised to the triangle, and it's set equal to the square. So hopefully it'll take some getting used to, like looking at it, but with practice, I feel like we'll get nice. All right, so let's just keep this in mind. So let's kind of like put that on the back burner. All right, so we want to write each equation in the exponential form. All right. Also, it is worth mentioning that there are about 7 different log properties, which I'm not going to cover all 7 in this video. It'll be broken up. So I'll cover about 4. And then just know that there's some other ones on the horizon. Okay, so first off, we want to write each equation in exponential form. So log base 3, 81 is equal to 4. So we can kind of like, so again, 2 ways of doing this, right? If you're the analytical type and you can like put this together like quickly without all the shapes, and then you can kind of see it, right? 3 raised to 4 equals 81. See the little swirl? This swirl little thing is going to happen every time. Every time when you have a log, right? It always starts at the base. You raise it to whatever's on the outside of the equal sign. If there's nothing there, we'll put something there, and then set it equal to whatever the argument is, like the input or the X value. There ain't an X here, but it's the input value. So again, 3 raised to 4 equals 81. All right, now if you're not as sharp, right, like you're not as quick, and you need shapes and colors, right, like, I get it, right? So there's the cloud. So that's the part that I'm going to write here. And then I know that it's raised. Here's my triangle that's outside. I'm going to raise it to that, right? Because we're matching the picture. That's in the top right hand corner. And then the argument, or the 81, that's the square. I don't know, I like this way. I like it like this. So we just took a log and we converted it to exponential. And that makes sense, right? 3 to the 4th power is 81. 3 times 3 is 9, times 3 is 27, times 3 is 81. So, I mean, that's it. Okay, let's look at the next one. I'm going to do it both ways. So 49 raised to 1/2. So 49 raised to 1/2 equals 7. And now think about that. 49 to the 1/2 power. 1/2 power is the square root. Square root of 49 is 47. So we've successfully converted. So here's an example where it's log base 10. So I know I said that typically you don't see a base 10, which is true, but in this case they put it. All right, so 10 raised to -4. So 10 raised to -4 equals 0.0001, right? 10 thousandths. And that makes sense because if you have 10 to the 4th power, so 10 times 10 times 10 times 10, so basically 10 with 4 zeros, but it's negative, right? So it's going to go to the bottom of a denominator. 1, 2, 3, 4. So 10 thousandths. 10 thousandths. And that's, convert that to decimal, right? 1 over 10,000 is 10 thousandths. Converting that to a decimal, tenths, hundredths, thousandths, 10 thousandths. So 1 10,000ths. Now notice the little swirl that I'm saying, that always happens. I guess I kind of didn't do it in the second one. So let me give you a visual. Okay, and then I'll do the same thing. Okay, so those are the starting with logs and converting to exponential. Again, we're just following the picture, like following the schematic. And then once you get better, you won't have to draw this anymore. You just think about the swirl, right? The base raised to whatever's on the outside equals the argument on the inside, right? Okay, so now let's go the opposite direction. Let's go the opposite direction. So now we have an exponent and we want to write it as a log. So I can write it up here so I don't have to keep zooming out. All right. So the little double-sided arrows is if and only if. If and only if, right? It means you can go back and forth. All right. Here's my base. So log base 10. Again, I typically didn't have to write it, but I'm doing it just to emphasize what it is, where it goes. And the outside part, that's going to go here. And then last, the triangle, -4. And that's it. And if you think about it, it goes 10 raised to -4 equals this. And that's exactly what we started with. Right, like a quick check. All right. The next one, so log base 4 equals -2. It doesn't matter the order you go in. I go however. So this is going to be 1/16. And that makes sense, right? Because again, 4 raised to the -2. That's 4 squared, which is 16, but negative, so it puts in the bottom. So 1 over 16. And that's exactly what it equals. Right, like your quick little swirl check. Okay. What's log without e, right? So let's not freak out, not panic. Let's stick to the script. Stick to the script. So we have a base. We have a base. So log base e, the one's a triangle. And then there's the square. So this is saying base e raised to 1 is equal to e. Which brings us to our first property. Our first property is that. So let's see. Where do I want to write it? So property number 1, I guess. Doesn't matter the order. Is this truly number 1? It's number 1 to me. So you have log, whatever that base is, right? We'll call it base b, since base starts with the b. So log whatever that base is, and if that same value is the argument, the answer is always 1. I don't want to use red. The answer is always 1. And that should make sense, because if you think about it, if you take any number, any value, and you raise it to the first power, well, it's going to just equal whatever that number is, right? 0 to the first power is 0. 1 to the first power is 1. 2 to the first power is 2. 3 to the first power is 3, right? Like this goes on and on and on. So anything to the first power is the original thing. So this is the first property. So if you can notice the properties right away, you don't got to do all the calculations. It's, it's basically saving time. So there's that one. All right. So that's converting. I mean, it's kind of fun, right? I feel like it's kind of fun, right? Like it's colorful. Okay. So now let's determine the value of each logarithm without using a calculator, right? No calculator, just off the dome. So log 5, base 5, 125. All right, so notice there's no equal sign. That's because I'm going to bring the equal sign. I'm going to set it equal to something. What do you want to set it equal to? It don't matter. You can set it equal to X, Y, A, B, C. Honestly, it doesn't matter. We can set it equal to X, because X is the unknown. Maybe we should use red. All right, it's equal to X. So then what I'm saying is we're going to convert it, right? Because I don't know what log 5, 1, base 1, 5, 125 is. Like, I don't know what this is. But if we convert it, right, 5 raised to X equals whatever this is. So equals 125. And now it comes a little bit more clear, right? 5 to some power is 125. So 5 to what power? 5 times 5 is 25. Times 5 is 125. So 3. X equals 3. So X is equal to 3. Now, I get it. There was no X to begin with. We said that. So the answer is just 3, right? Because log base 5, 125 is equal to 3. So 3 is the answer. You understand what I'm saying? So it's kind of like we made up our own little variable to help us through our thought process to figure out what the actual answer is. So, it's not X is equal to 3. The answer is 3. You get me? Okay. So I always set it equal to X, or I set it equal to something. And today I'm feeling like X, right? So 6 raised to something equals 1 over 36. Okay, so we can do some work here. We can do some work here, or we can rewrite 36 as 36 to the negative 1 power. right? That brings it up. That clears the fraction. But then, I mean, you're probably already at the answer right now. I'm going to rewrite 36 as 6 squared. And that's raised to the negative 1 power. Property of exponents says that when you have exponent raised to exponent, you can multiply it. So 6 raised to the negative 2. So if you think about it, right, we have 6 to the x is equal to 6 to the negative 2. Now, the bases match. So x is equal to negative 2. So the value is equal to negative 2. Okay, so I feel like if I keep going at this pace, it's going to take all night. So we're gonna step it up. Right, we're gonna step it up. All right, e raised to x equals this. So e to the x is equal to e. All right, cubed root. Cubed root. We can rewrite cubed root as the 1/3 power. Right, 1/3 power. 1's the power, and the bottom is the root because roots grow underground. So 1/3. Okay, so we can equate the exponents together. X is equal to 1/3. X is equal to 1/3. E to the x is equal to 1 over e to the 4th, which is basically e to the negative 4th. So x is equal to negative 4. So 2 raised to the x is equal to 32. So 2 to what power equals 32? 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So 5. E to the x, e to the 1/2. Where'd the 1/2 come from? It's square root, right? It's a square root. So the bases match, so the exponents have to match. So the value is equal to 1/2. Okay, 5 raised to the x equals 1. Okay, 5 to what power equals 1? Well, there is a property. It's 0. It's 0. Anything, the property is anything to the 0 power is 1. Right? Anything to the 0 power is equal to 1. So in this case, it's 0. Right? The property is that x equals 0. Right? Anything to the 0 power is 1. This is an exponential property. So 3 to the x equals, so 3 to the x is equal to 1 over root 3. Well, root 3 is 3 to the 1/2 power. But because it's in the denominator, that means it's negative 1/2. Right? So you got to be able to quickly go back and forth between square roots and bring things up from the denominator, right? It's got to be second nature at this point. So x is equal to negative 1/2. Negative 1/2 is the value. Negative 1/2 is the value. Okay, so let's back up for a second. Let's look at property number 2. All right. I kind of glanced over it just because I got excited. So property number 2 says that if I have a log base b and the argument is 1, this is going to equal 0. So whatever the base is, it don't matter. Log base whatever to the 1 is equal to 0. So this is the second property. Just throwing that out there. All right, so we have 81 raised to x equals 9. So 81x equals 9. What do you think? Square root of 81 is 9. So if I take the square root, but that would mean that x has to be 1/2. Doesn't it? X has to be 1/2 because the square root of 81 would be 9. Okay. The last one's always a doozy, isn't it though? Okay, so we have a log inside of a log. So the best suggestion is to work inside out. Now, you may watch other videos where they say something else, but right now you tuned into me. And I'm telling you, I always go inside out. So looking at the inside, 8 raised to something equals 64. So x would have to be squared, right? X has to equal 2. So what's that mean? That means since this whole thing is equal to 2, right? The whole thing, this whole thing is equal to 2. So that means log 4 base 4, 2, that's equal to x. All right, again, not the same x that's up here, like a completely different x, right? It's equal to something. So 4 raised to that is equal to 2. So 4 raised to x is equal to 2. And in this case, x is equal to 1/2 because the square root of 4 is 2. So look, we'll do it like this. So first we had a red x, right? And that red x is 2. That's this 2 here. And all this is going to be equal to a blue x. So the blue x, that's what the entire thing is equal to, right? In this case, it's 1/2. Okay, and that's it. That's it for the notes. So let's cover one more property that I didn't really mention. Okay, so another property. So how many we got? 2 so far. Okay, it kind of goes in line with this sixth example from the beginning. So if you have log base e, right, and then again we can call this property number 3. It's not really in any particular order, but log base e to whatever argument, this is equal to ln. ln. You might see this in a Inspire. I think it's in, but it's ln. ln. And it's usually a lowercase l. I just put like a little thing on it just so you can see that it's an L. So this is called natural log. Natural log. So ln is natural log. So log base e x is natural log. And this particular rule plays a pretty huge part later on. But just know that when it comes to logs and logarithms, natural log is a very natural log to talk about. No pun intended. All right. I think that's it for right now. So I think this is all you need to be successful in terms of converting logs to exponentials. Smash the subscribe button if you haven't done so already. Hit the notifications bell so you never miss a video. And like, subscribe, comment. Peace.